What is up, everybody? Welcome to the Ham Radio Crash Course. Welcome to Saturday. Back in the shack from a glorious Orlando Hamcation visit. I feel like it's been nigh on 2 months since I've been in my own shack to live stream. But today we're going to be talking about a fantastic rotator. Some people call them rotators. You can do that if you want. But yeah, we're going to be taking a look at the PSR 100. Link is in the video description. Unfortunately sold out because they sold out from Hamcation. But I'm going to talk about it. I'm going to do some final assembly stuff and a little checkout because I need to get me a rotor for my VHF UHF satellite work. So hang on tight, enjoy the memes, and we'll get started real soon. What is going on, everybody? I hope you had fun last week. I'll tell you, I have been live streaming from shows for years now, literally years. I know my first hamvention was 2019 before COVID, and then once we came back from COVID, I'm like, I'm live streaming all of this stuff. And I have fought tooth and nail and with folding dollar bills to figure out a way to live stream. And the Hamcation that just passed was the first time that I actually felt happy about a live stream. And so a ton of people have reached out asking me, how'd you do it? And I linked everything in the show notes. So it's actually not very expensive. Now, there's one caveat to this. You got to have T-Mobile. You got to have some decent, not great, just decent T-Mobile. And so I'm using a T-Mobile hotspot. I used a DJI mobile gimbal and some DJI mics. That was it. All my multi-$1,000 setups with really nice cameras and all that stuff. A lot of that doesn't matter if you can't get an internet connection. And even if you get an internet connection, it's like, how much data are you really going to push, right? So I did throw some stuff in the show notes to check out. I will cover this up front since I got so much questions about it. So that hotspot the service is provided from T-Mobile/Sprint, but it's through something called Calix. And I don't know the whole background on all this. You can look it up. But Calix, basically, they are the byproduct. They call it the Calix Institute. They're the byproduct of a class action lawsuit that went down against T-Mobile and Sprint. And it was because of their throttling of hotspot users. And so this company shows up and says, well, as a byproduct of that, we're going to create the Calix Institute. You can do, you can basically become a member, and we'll send you a hotspot, and then you'll have this unthrottled T-Mobile data experience. And it's been fantastic. Now, there is a little bit of money in this. It's $700 for the first year, and that includes the 5G hotspot, which that is a 5G hotspot, so very nice. And then you get a full year with, I think, like no data throttling. I think you have to go to like 25 gigs before you start getting deprioritized. Still, 25 gigs is a lot for live streaming. And then every subsequent year, it's $500. That's it. That's the cost for data. So I basically converted all my data stuff over to using this thing. And as our friend Zach over in the Discord will tell you, this is actually a pretty cool device because if you flop open this little door, so if you're on Ubiquiti or things like that, it actually has a network adapter in here. So you can connect this to your home network, leave it on and just charging in the background, and then it will default over your data. So if you're in an area with like data dropouts, then this will do pretty well. So that's the secret. A lot of people ask me. Thought I'd cover it right up front. Also, something. So this getting back on the topic of this rotor, right? Let's talk about this rotor for a second. Yeah. So where is it? Yeah. This PSR 100. So I've seen this a couple of times now at the shows, and what really put it on the radar for me was Kyle, AA0Z. And you can watch his video that he did with the creator. Let's see, WA4MCM. And you can go through here and you can watch this really nice live stream. I linked to it. You can see a lot of background on it. You can see some demonstration of them playing around with the antennas. Really good stuff. You should go do that. But the advantage of this rotor is you can use your elk antennas or your arrow antennas. The brand new ARRL satellite antenna should work with this, with maybe some custom prints. We can talk more about that as we go along here. But really, really nice. Oh, you know what, Michael? I'll tell you why not use Starlink. Go check out Jason's live streams on the days that he was live streaming. The first day he was using a Starlink, he did not enjoy it. He used my hotspot for the second one. He said that was a way better experience. That worked way better. Again, we had decent signal. So Starlink has dropouts when it comes for live streaming, right? You have to wait for satellites to come overhead. So that's the downside of Starlink. The hotspot works great, though, when you're walking around. Starlink's not great if you're walking around. You kind of have to be stationary. And I walk around the show, right? Obviously, but anyway. So this is a 12-volt AS-L rotor. So azimuth, and you got the Z for tilt, right? So you get rotation and tilt. You hook your antenna up to this, and you can have it through the use of some software, either in your computer or using something like this SAT box above my head, control the rotor and point it where it needs to go. And one of the best things about this is this device is Wi-Fi controlled. So from my computer, I can actually issue commands, or the application that I'm running for tracking satellites can issue commands. And then I can just focus on the radio. If you go with the SAT box that's above my head, it will also do cat control. What that means is when you have that box connected to your rotor and connected to your radio, you are also changing frequencies and adjusting for Doppler appropriately. Huge. Very, very powerful capability. So I love that. I loved it so much that I was like, I have to buy this. Absolutely great. So we're gonna finish assembly. I did some soldering. It's basically built. I built the wiring harnesses, all that stuff. It's very straightforward. I'll walk through the instructions when we get started with that. But I have to show this because a lot of people didn't catch it. One of my favorite things from the show, I captured, didn't even realize I captured it until I edited my shorts. And so I want everybody to pay attention to Kyle here on my shorts. It's one of my favorite things I've ever seen him do. It's in a couple seconds.
I'll see you later. Yep, that's right. Ham sign. We got ham sign. Got the breeze. This is amazing. This is why you want to come to Hamcation. Beautiful. Absolutely beautiful. Look at this antenna. That's crazy.
We got chips back there if you want chips. Okay. Let's go get the chips.
I laughed so hard at that. He's like, okay, we got chips over there. And then you see him go into manager mode and he goes, let's go get the chips. I laughed so hard editing this. I have to go back and do it one more time. It cracked me up.
We got chips back there if you want chips. Okay. Let's go get the chips.
We got chips over there. Let's go get the chips. That was the manager point. Like, you saw his figure was out there, and he's like, I'm not getting the response I needed. It looks at Rob and goes, let's go get the chips. I laughed. I laughed so hard. Okay, so let's walk through this a little bit. Let's see, what's the best way to do this? Doop-a-doop. Yeah, let's just line it up. So if you buy it off the website, I appreciate they're sold out. I think it's $320 for those who ask, plus shipping, depending on where you live, of course. Not inexpensive, but when I start showing you the quality of this thing, I think it speaks for itself. $320 is not bad for what it does. But okay. Yeah, so then the next one is once you buy it, there's a link to the download site for all the supporting files. And so there is both a operator manual and then an assembly manual. And so I'm looking at the assembly manual right now, and here it is, right? This is what it looks like up close. And so you have physical control for elevation and rotation. You've got all that stuff there. It runs off of 12 volts. It comes with a dongle. It's Wi-Fi enabled, etc., etc. But let's look through this for a couple of minutes just so you guys get the idea of what the installation looks like, or the assembly. So breaks down all the parts. I did a breakdown of the parts. I had everything there, so it was good to go. You're primarily going to be playing around with this circuit board, and it's just like any kind of kit radio that you'd expect. Advantage here, because it's not a radio, though, you won't be winding any toroids. It's very easy. Got a couple of diodes, capacitors, and resistors. There is a ADC module as well as a microcontroller module. You need the microcontroller module to work the stepper motors, that whole thing. But here's the breakdown on what the assembly looks like. So gives you some kind of details on soldering. He did a very good job here with the instructions, explaining how to appropriately solder. And then you start going into the actual soldering, and it points out areas on the board that you need to make sure you're soldering to. Talks about, the bands of the resistors, red, black, gold, and where they go, R1, R2, R is for resistor, right? And goes down the list. And then there's helpful pictures along the way, like don't screw up the alignment of the diodes, right? The way that the power ports go together, there's little dashes on the side that has the pin slots. Really, really good instructions. And there are a couple resistor spots that you need to do the vertical orientation. So those are the 4. There's, I think, 5 total that you have to do in the vertical alignment, which are pretty easy. Very good, helpful tips. He highlights them, so it's very nicely done. All your MOSFETs are, again, noted by this extra dash, and he takes the appropriate amount of time to remind people of it. Very, very good. Very straightforward. The design was the documentation or the instructions is very good. So I appreciate that. Grayman Poda, 29-month member. Thank you, buddy. I appreciate that. Followed up by Corpse a lot, my buddy. Josh, you need to stop spending my money for me. I have a wife for that. I also got a kid, too, so I'm also taking food out of his mouth, right? Or her. I forget. A boy or girl. I forget. I'm sorry about that, buddy. All right. So, continuing on, you can see this is the alignment of the boards for the microcontroller, and then even goes into building the wiring harnesses, how he recommends doing it with the heat shrink tubing that's provided, going through the whole list, and so on and so forth. Now, we've advanced a little bit here, so I'm going to go ahead and, oh, yeah, by the way, there's the Wi-Fi board. You need to have that. That goes into your computer. Need to have that. But there's also a accompanying app that you can run with this device that is available on his website. I am running the app right now. In fact, you can see it's right there in the right-hand side. And yeah, it's connected over Wi-Fi. It gives you a readout. There is a calibrate process. I think if I click it, never mind, let's close out of that. But I've already done the calibration. So I know that the motors are all working. Our potentiometers are good. Our switches are working because we actually tested for both motor side, and we were able to shift things up and down. I got that out of the way first. I will tell you it took me about an hour and a half to kind of do everything and then run through the initial test. I was not in a big hurry, but you should probably take your time. There's nothing in this that is going to be anything difficult for anyone who's built a radio before. This kit build is very straightforward. That's for the soldering. Where we're going now is actually assembling. I have not done this yet. We're going to do this together. At least I'm going to do it, and you're going to watch me. And that's going to be the rest of the show. So, all right. Chris, member for 30 months. Thank you, buddy. Appreciate it. New member, or not new member, 45 months from Arthur says, thanks, Josh. He's got a little beer stein for me there, bud. I appreciate it. Thank you so much. That is a good question. VE9 ASN asks, will it handle the Alaskan? That I don't know. You should probably reach out and ask. The Alaskan is a big arrow antenna. I can't even really manhandle that thing. You need to use I need to use a tripod. I had one for a little while, and I swapped it out and ended up getting the just the 3-element 2-meter one because it was way too big. Yeah, Hillbilly Ham, I hear you. The good news is that the parts are not surface mounts. The surface mount ones are already done. It's all just through holes. So I hear you. If you can't operate with those, I get it. That's difficult, but yeah. All right. Let's go back to the overhead here, and I do have a little bit of webble-a-do here. Let's scroll down here. We've gotten through the calibration, and now we're going to get into the actual assembly. I did go ahead and put in that press-fit nut. Now, I will note, guys, follow this advice. Normally when I see these little nuts that go into a 3D print, I almost just always take my soldering iron and use it to push the nut in. The soldering iron heats up the brass fitting or whatever it is, copper fitting, really hot, and then that just presses into place. This does not call for that. It's opened enough that you actually use super glue to hold it into place. So don't just assume that you're just going to heat press it in. Don't do that. There's actually not enough material there to do a proper heat press. So I just did a super glue job. All right, let's go back over here. Hey, VE9 ASN, thank you for the super chat. I appreciate you, buddy. There's nothing written there, but I'll give it a thumbs up. Thank you so much. Appreciate you. All right, let's continue. I'm gonna get some of this detritus out of the way and grab my beer, and we shall begin. I will be watching the chat though as we go along, so feel free to let me know what's going on there. All right, so the next thing we got to do, or I got to do, is push the board into place. I will have to unplug things now, so I will leave the Wi-Fi board connected, but we will be disconnecting the power to the actual unit. Also, very important, if you don't have one, get yourself your Harbor Freight $15 Drill Master heat gun. I use the heck out of that for some of the heat shrink tubing, but there you go. All right, sat box will come in later, hopefully, if we got enough time. I kind of want this thing done tomorrow because I've got an event to go to for the kids, and I'm thinking about dragging this along and my elk and all that other fun stuff. So I'm going to try and knock this thing out. I don't know how this live stream is going to go, but Kyle built this over the course of like 3 live streams, and each live stream was like 2 hours. So I think I've only got the easy part out of the way, to be honest. I think the assembly is going to be a little bit of a slog. I think it's probably a little bit more than the time it took to build this. But anyway, I'm going to disconnect the power. We have lost our light here that was on the board. I do have a Kenwood D72. Yeah, that's actually what I would be using in the short term for doing some stuff. I can't imagine that that's going to be as effective as some other things, but, you know, I think I may have another radio on the way to me that may have a little bit more power, mayhaps. Now, the SAT device that I'm using, I'm unplugging all these little guys right now. Come on. These are very tight. I would hold on to all the wires very firmly right against the connector and pull up. But that worried me a little bit. Ooh, yeah, these are very tight. I imagine after doing this a couple of times, I'll loosen up a little bit, but I worry about messing with the, oh, God, that's in there good. Okay, so here's our board. I will mention, yeah, look at my solders. Clean. I didn't clean the back or anything, but not bad. Pretty good. Ooh, it's a little warm. That MOSFET heatsink's a little warm. I will mention that you do have to solder in the pin headers for these boards to slot into. And the explanation that's in the instructions is done really well. After you get them nice and perpendicular, which they need to be, what I did, and this is a bit of a cheater tip from me to you, I wouldn't do this in all cases, but if you can keep the heat short, I took the other side, the pin side, and I inserted the pin side in, laid this flat on the table, and then laid the board right on top of it because it's pretty even spread. And then I just soldered them into place. That's all I did. I just laid this down and then boom, 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 hit them with some light solder. And so that's the board. All right, so next step. I went through and I put little Sharpie marks on this guy. So now we need to insert this. By the way, it's not coming through. Maybe it is, maybe it isn't. This is some real high-quality prints. This is not your traditional PLA. A lot of people use these outside. They have very little issue with the heat. However, it will change color in the UV. So keep that in mind. In fact, if you're so inclined, you may actually want to just go spray paint this. But anyway, doesn't really matter. There's a slot here that lines up with the USB-C. So we're going to go ahead and throw that guy in there. And there's some clips that'll hold it into place. So I'm just going to kind of get it into place and then push down. Bam! We're in. Just like that. Instructions there in green say, yeah, you can use your thumbs. Plug the connector to 2-connector long assembly for the toggle switch into the connection C6. So a toggle switch is, let's see, which one is the C6 one? C6 is this guy. So that's going to be our on-off toggle. And that is a on-off. And as the instructions have said, make sure that you probably leave this in the off position, and it is listed there. So I'm doing that now. Boom. Look at that. Beautiful. I probably could have went in there with everything connected, but it's nice to follow the instructions again. Remove the control nut from the back of the panel mount DC power receptacle and insert the conductor. Oh, wait. Wait, am I doing this wrong? I am doing it wrong. Very, very wrong. Where is... Ah, yes. I did this wrong. Maybe? We'll see. And remove the nut here. And we're going to go through the hole here for the 12 volts. And through there. It calls out using needle nose pliers at some points of the installation, and I have kind of looked ahead a little bit on the instructions. You probably will need needle nose pliers for this. It starts getting a little tight in here. And then DC is going to be CN3, is that right? Slide the control nut over the assembly and screw it in place. Be careful not to cross-thread the nut. And then it goes into CN3, which is that guy right there. Straight down into the board. Boom. Okay. What's next? Remove the control nut from the SPDT momentary on-off toggle assemblies. And adjust the remaining control nuts so about 1/3 of the threads are available. Insert in the manual elevation. Insert the switch assembly into the manual elevation. Okay, so we're doing manual elevation. So this is elevation, and that's azimuth. So this is a momentary switch where it'll switch down, and then it goes back to off. Switch on, it'll go back to off. So we're going to go out with these guys. And then we're going to use this middle guy to kind of set the depth that we want. I nailed it on the first. No, I did not nail it because we need a couple more threads. So we're going to go back a little bit. Nope. Nope. Take your time. Do this right so it will be a joy to operate with. I could see actually taking the time and actually going in there and kind of tightening these down with some needle nose pliers or whatnot. So that's elevation, right? Elevation up and down. Where does that go? Did it say there's a lock washer? I didn't even have a lock washer, so you already discarded it. And plug the controller to the end of the cable in the manual LSW CN9. CN9. We got a niner. And that's this guy. Hello now. Come on now. Come on now. Go ahead. Go ahead. What are we doing here? There we go. Right in there. CN9. Like a show. Our next momentary switch. This guy. And if I'll pre-gig this one. Oh, come on now. Gonna work here? We focusing today, guys? There we go. Ooh, we're cross-threading a little bit. Got a little bit of cross-thread action. Calm down now. Oh, just a little tight. The focus is a little out of whack today, but here you go. So now we got azimuth counterclockwise, clockwise, up, down, elevation. Now, this is manual control. You can just go in and manually do this if you want to, which is great. I love the fact that you can just manually do that. But, of course, we want to have this automated. I'm not doing this because I want to be touching antennas. If I did, I'd just hold the elk antenna up and just go nuts, right? I've got a handle on my elk. I'll just manhandle the elk. I want to make this as simple as possible for chasing those big field day contacts, right? Or I don't know. Activate a park via satellite. That'd be a big goal. Has Digital Rancher done that? Somebody in the chat tell me if Digital Rancher's done that. I'd be curious. So yeah, we look like that. This completes the main body layer 1 pre-assembly. Please proceed to the next section. Main body layer 2. This is for the azimuth motor. Okay, so this is when it starts getting serious because now we need to start rotating the actual antenna bit. Uh-oh, here we go. Wait. Are the wires oriented correctly? So up is up and clockwise is clockwise. I think it's adjustable, believe it or not. I think we can go into the configuration and change that after because it didn't specify. The only thing it cared about was that for our 3-wire momentary switches, that the black wire was in the middle. And it was like, yeah, we'll sort out the rest later. Don't worry about it. This guy, though, where does this guy go? This is going to be on the flipped side. So we'll see that here in a second. He activated a park. I mean, I totally believe it. I wouldn't be surprised, but yeah. All right, main body layer 2. Using a fine Sharpie point, I have done that. Uh-oh. Use a 3/32 Allen key to insert the set screw into both set holes and couplers using the motor that was pre-assembled in step 36. Okay, so I do have a motor that I have gone through and already rigged up. There's a step in the wiring harness process where you gig up one of these guys. So I'm not going to try and lead the witness here because I didn't say to put this on top, but I'm also set up here with this guy. So what are we doing? We're going to attach the rotor nut, which is this guy. Should be anyway. And I have myself a 3/32 Allen key right here. And how much gap? Well, it's not a lot of gap that it's asking for in the instructions. So I'm going to try and follow it to the letter. And that gives a little bit of keying action, so this should not rotate. Yep, pretty good. Pretty locked in. Oop. I got cut metal pieces all over because I was working on this literally before I had to go get Edison from a bowling birthday party and get ready for the live stream. When inserting the set screw them so that they protrude very slightly into the coupler's center hole. This will ensure that the coupler can only be inserted with the set screw facing the shaft flat side. Yeah, so we're using keying, if you will. So mount the azimuth. Ooh, okay. So I think we are at the point where we do in fact need to. Oh, did I already screw that up? No, I guess the hole's big enough. Is the hole big enough? It is. It is big enough. Yeah, okay. So we're going to mount it so that the bits here are like so. And it's already dialed in for us, I think. Yeah. Maybe? Yeah. Okay. There's a whole pile of screws in this kit, so I'm going to go get those now. Dave, I'm sure you're right, but at the very least, I think I can just rotate the switch. Oh, red wire up. Red wire is okay. It's up. I'll just take your word for it, and I'm gonna rotate this one right now. Why not? If you're saving me some headache later, I will trust my buddy Dave. Oh wait, Dave's got one. Why am I trying to? Dave's got one of these. This is one of the ones that has gotten all heat. I remember that, Dave. Now, thank you. Okay, we're gonna take Dave's word as gospel for any and all of the commentary henceforth in this build. So thank you, buddy. Dawn has replied. Unfortunately, the Alaskan arrow is too heavy. Okay, so thank you. I almost want to add super glue to these threads and lock them in, but I know that's probably a bad idea right now, so I will wait on that. Oh wait, I didn't even check which screws we're using here. Hold on. I know once we go into 3D prints, it's going to be a little rough, so I'm going to check that we got the right screws. Nope. These are the fine thread. Yep, I think that's it. Yep. That's beautiful. I'm not torquing these down very tight because we still are going into 3D print, so. Insert the 6mm by 6mm by 60mm D shafts. And these suckers are labeled. Look at that. 60 by 6 D shafts. And it is flat, so we will get the keying action of using our Allen keys here. My Allen key is a little too tight. What happened to my other Allen key? Why did it work on that one? What's going on here? There we go. All right. We have the D shaft. This completes the main body layer 2 pre-assembly steps. Please proceed to the main body layer 3. Okay, main body layer 3. Here you go. We are going to take our 10K tapper potentiometer. Oh, that's blocked a little bit. That transmits the azimuth angle to the PSR's 100 microcontroller. It is mounted alongside the 45-tooth hub mount gears. Please proceed to the following steps to complete the main layer 3 pre-assembly. Okay. Remove the top nut washer from the threaded shaft. That was pre-assembled in step 32. Okay. So I have another guy here. Oh, and which one is it? Oh, it's this guy. Control nut. Top washer coming off. There are 2 washers, so it only mentioned the top washer. Rotate the potentiometer so the tab fits. Place the top washer and secure with the control nut. So washer go back on. Top nut go back on top of that. Easy. Yes. Okay, now we're getting into some gearing. I need a sip of my my beverage for this. Now, for everybody watching, I have already verified that my motors and the control assembly, all that stuff is working. So if we screw up at this point, it's because of mechanical issues. At least that's how I would approach this, but don't know. Oh, wait. Is that the right one? Nope. Is that the right one? Nope. This is the right one. This is the 45 tooth hub mount. Okay, we got our hub mount gear. All right, bore set hub. Locate the 1/4 inch bore set screw hub. Interesting. So this is the 6 millimeter D bore. So it's not that guy. This is the 1/4 inch bore screw hub that we need. Fantastic. And yes, all these are labeled both as a product ID, but then also, there's an Allen nut or a screw here. I'll leave that on the side for now. I am inevitably going to need that. And there should be holes that line up with it, like so, and there are. So, okay. Use 2 M4 10 millimeter panhead screws. Interesting. So it wants only the 2. Okay, hold on. This guy here. Insert panhead screws, secure the gear hub to the hub identified. Use 2 holes that are on opposite sides. Okay. So these should be the panhead screws that we need. Are they? No. I think they're going to be coarse thread. Which ones do the... Wait, how big are they? 10 millimeter pan screws. 10 millimeter is going to be more like this guy. Is that right? How much do they protrude? Yeah, these are them. Okay. Okay, good. And then we got to find a hole that is opposite, which is these guys. Good. All right, we got our gearing assembly. Turn the shaft of the azimuth angle potentiometer mounted in step 74 about fully counterclockwise. What? A what? Okay, hold on. What is this saying to me? Turn the shaft of the azimuth angle potentiometer mounted in 74 above fully counterclockwise. Mount the azimuth gear assembly to the shaft such that the set screw Is this the wrong one? Oh no, that's it. Oh, I see. Because we're going to have to go through? It needs to go onto the potentiometer. Like that. So we've got this guy. Here's the set screw. Interesting. Expect somebody to start yelling You're doing it wrong. That's fine. Tell me. Tell me if I'm wrong. Tell me now before I screw it all up. No, that's not. That's not the one, kids. Wait, what is going on here? Oh, it's a 2.5 millimeter. Okay, so we're switching between standard and metric. Okay. Now, there is no... Okay, it is rotating. There's no D kind of cut. Ah, it's accessing the screw later. So, all right, we're going to put it over on this side like that guy right there. I'm getting a thumbs up from Dave in the chat, so we're going to leave that there for that right now. All right, this completes the main body layer pre-assembly steps. Please proceed to the next section. Elevation motor mounting bracket. All right, this is where it starts getting real. So we've got the elevation bracket, which is right here, this guy. And so we're going to set that right there. Install the two 6 millimeter inner diameter and 14 millimeter outer diameter ball bearings on the bracket's vertical arm. All right, let's do that. These just look to be press fit. Is there a lip of some kind, or are they just held into place? I think they're just held into place. Yeah, that's good enough. Oh, they are. These are radiused. So can we get a shot here? Can we get the chips? Can we let's go ahead and get the bearings. So the lip's a little bit wider here, and it actually indexes with the lip of the print. Dude, I'm telling you. So right now, this is, in my opinion, from what I've seen, and I appreciate it. I haven't used this in the field yet or anything like that. This is one of the better ones that's portable from my point of view. And I am squeezing here a little bit of give, but it's pretty rigid. The print is not like PLA. I don't even think it's ABS. I don't know what the material is, but it's not that. And yes, the instructions calls out exactly the thing that I was showing, is that there is a recessed edge. Oh, now we're getting crazy. We need to insert the shaft of the 12-volt 2 RPM motors, the one with no wires yet. That's very important. Let me get this out of the way so you guys can read along with me here. Yeah, the one with no wires yet, because we're going to have to run that up to it and solder. Using 4mm 3 M3 6mm panhead screws to secure the motor bracket. Now we're getting crazy because we're going to have to go up and over here like this. Oop. Oh, look at... Wait. Oh, through the whole... Duh. Or not. Yeah, oh, there we go. Pretty tight fit there, fellas. Did it only want... Okay, that's fine. We'll figure it out. Okay, I'm going to move some stuff here so I don't lose any screws. But 6mm. Let's double check those guys. That's a pretty tight fit. Yes, it's those guys. So I'm going to hand thread, see if we got it. I'm going to get a much smaller screwdriver here to do this. Hi. Beautiful. Thank you, Klein Tools. Or, sorry, Veritools. $370 people watching right now. Thank you so much for watching. Yeah, so we got what is it? What do we got now? What are we down to? FT3? Is that what did it just hit the scene? FT3 kids? Are we rocking FT3 now? I may be playing some FT3 on the after chat. We'll see how it goes. Why would I take out the bearing when I can just well, the whole I'm going through that hole. And then if I the screws are recessed far enough down that this one is a little bit better aligned for that. So, FYI. Oh, is FT2 the new? Wait, did we skip right past 3? What's going on here? Oh, because it's got to be multiples, right? Okay. FT2 is the new kid on the block. Every bit as fast as the FT4s in half the time. Or just about. We call it 7-minute abs. 7-minute abs. This is Ham Radio Crash Course After Dark ASMR. Sup, Josh? It was great to meet you in Hamcation. What's up, Patty boy? All right, we did it. Install the remaining 6-minute. Oh, it said to only do 1, so I've already screwed up. So there you go. First mistake on the chat there, guys. I just went and grabbed a tool that would allow me to handle it. Oh, here we go. I was wondering how this 6mm D-bore shingle guy comes into play. Prepare the 6mm single sub, our sonic hub, by inserting its 2 socket head screws into the respective threaded receptacles and loosely screwing them in. This will be tightened during the final assembly. Now install the hub into the recessed mounting hole in the base of the bracket. What does that mean? Oh. Which bracket? Oh, it's this guy? Yeah, it's this guy. We are now... Yeah, it goes on this side. Okay. Am I doing this correctly? I think so. This is when it starts getting real, guys. We're getting into crane territory. Oh, yeah. I like this thing. Scares me, but I like it. Loosely fit. Oh, I see what this does. Oh, wow, that's kind of a funky... That is funky. So check this guy out. So you mount this onto a bulkhead. So this is like a flat mount. And then you're going to slide in an axle of some kind. And yeah, I already know what's going to go here. We've got a D... one of these other rods is going to go into this. And then you use these longer screws to tighten it down, and it uses this friction of pulling in both directions. These are cool. This is the first time I've seen something like this. All you mechanical guys are like, yes, Josh, this is how you must do it in certain cases. You're all German to me. I don't know what to tell you. All you mechanical engineers are German or of German descent. I'm kidding, of course. Adam. Oh, wait. Was Adam materials or mechanical? I think Adam is mechanical. And then this goes like that. And then we're going to have to get some big honkers like that guy. that about right? Maybe? Oh, wait. I'm getting too ahead of myself. We'll see. This is too small, but let's just see if it lines up. Yeah, like a glove. Like a glove. That's what they say in the materials lab. This thing's so... Oh! Wait. Oh, because I did the screws on the wrong side. I'm an idiot. Yeah, that's my bad. That's my bad. Other side, Dave. Dave. What do I have the latency set to here, just so I know? Do I have this on fast? Oh, it's on normal. Oh, I'm sorry. Sorry to myself more than anybody, because it's going to take longer to hear your corrections. Hey, we do our best. What can I say? I forgot to set this. So, funny thing that happened when I set the time of the live stream. Sorry for everybody who showed up at like 2 p.m. Pacific time and was like, "Where's Josh?" My computer, even though it was totally connected to my house Wi-Fi, just decided to stay on Orlando time. So I've been rocking Orlando time since I got home, and it just was like, yeah, let's just roll with it. And so it's just been laying out YouTube stuff for the Eastern time slot for this live stream. I think a video I dropped to members was a little weird. And uh-oh. Where's the other screw? We've got a bit of a problem. Did I lose a screw? I literally put them all right here. Oh boy, here we go. It does call out 4, and there's definitely a hole for 4. There's another one of those guys. Am I blind? Where did it go? You all saw me. I pulled out. I'm sure that it was in the kit. I just don't know where I put it or where it put itself through my kinetic action during the live stream. Reminder, kids. No, maybe not for the kids, but reminder, adults. It's always best to do these live streams, when you're building something to have a bit of beer while you're doing it. Only 2? Oh, wait, no, the instructions say prepare. Oh, 2. I'm an idiot. Thanks, Dave. Love you, buddy. Glad you're here. Glad you're here, Dave. Okay, I like it. This kit is so well produced and thought of that when I'm missing a screw or like I see 4 holes, I think I must install 4 holes. And it's like, no, we're good. Yeah. Okay, so we got an extra screw there, and I'm going to torque these down just a touch. Okay, because we're We're going to go into this guy. I'm pretty sure it's coming up here. Good. We're not. Oh, yeah, there it is. Here is the point you've all been waiting for, at least I have. Mount the elevation arm assembly to the motor shaft by carefully slipping the end of the Sonic hub. God, I love it. It's literally capitalized. Sonic the Hedgehog made this. Between the end of the shaft and the elevation angle potentiometer as shown in the image. Wait. Where do we miss it? I didn't do the potentiometer, kids. What? When was the potentiometer mentioned? Oh my God, it was right here. Dave's not here, man. It's already happening. The wheels are coming off. Let's get that potentiometer on here. Because we're not going to be able to do it once we install the arm. Remove the control nut and top washer. Now that we're looking at the instructions. And this should be, yeah, it's right there. There's a little slot for the, that is keyed. For when you place this in the, in line here. Oh, God. There we go. Okay, one more time. There we go. We're almost done, friends. Oh, it's or almost a full hour here. We're gonna keep going. I need this done. I need this done. We're building this. Ooh, it's getting a little heavy, a little weighty here. All right. Now we can move down. Now we've prepared it. Yeah, you guys both. Kyle did this live, so I'm. Wait, Kyle did it live. I thought Kyle and I both been there, but not on a live stream with distractions. No, Kyle did it live. He was the man. Okay, here we go. So we are going to mount it this way. Important, if the arm won't fit when the flats are aligned, mainly due to contacting the bottom elevation, you will need to withdraw the arm, remove the hub, and rotate one. Oh, no. Where's the D? Oh, no. Oh, no. I think... I think I am the man that this is mentioning. Yes, I am the man it's mentioning. Oh, wait. No, I got it. Not me. Maybe other men, but not this man. Mount the elevation assembly, carefully slipping the Sonic hub, align the flats of the hub. Do not tighten the hub screws yet. See, I was about to just go torque the ever hell out of them. Slide the second through the opening. What? Mounted in the elevation bracket of the potentiometer and then the opening of the Sonic hub. Position the hub so it's 1/4 inch away from the elevation motor. Then, what? Okay, hold on. Now I'm... Do I have... Oh! Oh, ho, ho, ho! We need the gearing! I feel like I'm doing my kids' Vex IQ robot right now. They're literally doing robots right now, and I'm with you guys live. I understand what this is doing. That's so cool. Okay, let's walk through this because this is awesome. All right, so let me go back here. All right, so what we have here is we got a stepper motor attached to this Sonic hub, as it's called, and it has a D rod. It's a D-shaped rod that goes from the motor assembly out, and then there's another hole on this side. And you might be thinking to yourself, Josh, what goes here? Well, this guy goes there. And so we're going to install that right now. So this slides through here. What just fell off the table? Slides through here and aligns with the D bracket of the Sonic, the Sonic rings. Go right in there. And then we add the gear, this guy, to the potentiometer. And so what this is doing is it's giving you active feedback, or not me, but it's giving active feedback from the potentiometer back into the microcontroller to sense how much this is moved. It goes here. My bad. It goes like that. And so as this turns, it's going to rotate this gear, which is going to then pivot the, flip it around, is going to then pivot our potentiometer, which is going to give feedback on where this is at in space and time. Very cool. Very cool. I get it. Let me go back up, though. Yeah, Sonic gets all the rings. and the Chaos Emeralds. So let me go back to this, make sure I did it right. Slide the D shaft through the opening, ball bearing mounted in the elevation bracket, potentiometer into the opening of the sonic hub. Position the hub so that it's probably 1/4 inch away from the elevation motor's bracket, mounting bracket. Okay, so I've got it pretty flush, so I need to back it off a touch, and I did. That's about, what do you think? Is that about 1/8 of an inch right there, that gap from here, this white part, to the sonic bracket? Where are you at, buddy? You can go deeper and deeper, way down. Can I manually now? Yes. That's about 1/8 right here. What'd you say, chat? Is that about 1/8? Use a 3-minute. Okay, so we're gonna tighten this hub now, and I'm guessing we probably want to put focus on this one first. Oh, buddy. I'm gonna do the side closest to the motor first. Oh, okay, hold on. Do the side closest to the motor first. And then we're going to make sure that this is all the way in flush. And then I'm going to go in here and do not over tighten. Cool. This is freaking cool, man. This is so cool. And then I come in here with this guy. Oh, God. Come on. Yes. Delicious. I don't know, man. I don't know. The gearing is metal. The drive train, if you will, is all metal. That is a metal gear. It's all been metal at this point. It's metal. It's metal. It's going to do it. All right. Tighten or prepare the bore piston gear by inserting into the set screw. Slide the pinion onto the shaft and the elevation potentiometer such that you can still reach the set screw and tighten the set screw using an Allen wrench. Please refer to the image to the right. Very good. Prepare one of the 30 teeth 6mm D bore pinion gears. So this is a 6mm D bore 30 tooth pinion gear right there. I'm preparing it. Set screw. Not that one. Good enough. Now here's where we get a little, okay, it says prepare. Slide the tooth gear that you prepared on the previous step to the end of the elevation shaft as shown in the picture above. Position the hub so that the gear teeth do not mesh with the teeth. Leave the hub socket head screw stuck, but not tight. You'll be sliding the hub gear into the mesh in the pinion gear later. Aha! So, very important. We're not going to mesh these yet because we've got a zero. Oh, what just happened? That's not what I wanted. Oh, buddy, what? How far off are we? Oh, we are. We still got a bit to go here, kids. We've got a while. Oh my God, right here. We're right here. So we don't want this meshed up yet because we've got to zeroize this whole thing by probably aligning it to vertical or something along those lines. So we're just merely kind of setting this so that we can have it not mesh. We don't want the gears to mesh. Okay, so close enough. We're kind of semi-locked in. So now we got elevation, right? We got the motor for controlling the elevation. It will turn the arm. We got the gearing now to change the potentiometer. And then the potentiometer will report to the microcontroller. Okay, what are we doing? Are we focusing here? What are we doing? Anyway, this will report to the microcontroller to potentiometer to microcontroller to tell it where this is in space. So there's that. Now we need rotation, and so that's the next step that we're going to be doing. Love it. Aha, here we go. Okay, there's a big red here. Big red warning. Mount the 3-inch square ball bearing turntable to the bottom of the okay, using the 4 6/32 by 1/4 inch pan head machine screws. Okay, I got that guy right here. Ta-da. Uh-oh. Dave is bringing up something. Where is my shaft's not correct? What do you mean? Oh, maybe my shaft is too long? Is there another shaft? Do I have the wrong shafts? They're the same, right? These are both the same. I think they're the same. Well, this is where you'd go back and double check, so we don't want to mess this up. No? What happened here? No, we're not done yet. Sorry. Okay. Let's check. There's two. There's two. There's only two. And they're both the same. Maybe they changed the design to just use the same. Maybe he just, you know what it is, honestly? It's probably that it's probably easier just providing two of the same size shafts so that people didn't like incorrectly use the short one when they should have used the long one or vice versa. And then just that was it, right? Like they just screw it. We'll just do two of the same thing. That way when people did the rotation shaft, that it was fine. Same size. Could be wrong, but I'm not seeing another shaft. You're damn right. That's what I'm guessing too, is then he doesn't have to kit out two separate ones. Yeah, I think the only shafts I have are those two D shafts, and they're both the same length. So maybe it's a change. I mean, it would simplify it may be more expensive material-wise, but it probably makes his life a lot easier than having to like, no, you used the short shaft. You should have used the long shaft. Did you read the instructions? And he seems like a nice guy, so I'm sure he's super patient on all of his emails. But I'm sure he gets a lot of them because this is like, it's not a hard. Okay, this is not a hard kit. Everybody should build one of these if you have any interest in this. You should really go get it. But I can only imagine the amount of people that have problems with this. Like I'm drinking beer while I'm doing this. I wouldn't recommend people drink beer while doing this, but I have built a lot of sketchy kits. So I'm not gonna be like, oh, I'm an engineer, because I'm not this type of engineer. I did build a lot of Legos as a kid, though. Oh yeah. Oh yeah. That's the stuff right there. Get it in there. Good. Wait, it said do not over tighten bottom of the elevation bracket. Yeah. So this is a 3D print underneath this. So don't over tighten this because you will thread it. So you're basically cutting threads while you screw this in, and so if you bottom this out, you'll thread it. Or I should say, once you bottom this out, which you will when you're attaching the screws, your chances of threading it go up exponentially because it's just going to cut out all the remaining material. Yeah, done. One more. And I am looking at the pan head, like when it makes connection to the plate, I stop. And yes, I am using my Linus Tech Tips because they made an orange screwdriver. I had to go buy it. So that's what we got going on there. Yes, you need to come prepared to class. If you don't bring your materials, then it's on your own. Yes, I've probably voided all the warranties that of all the things I own at this point. All right, this completes the mechanical components pre-assembly section. Please, final assembly, kids. We are there, which means we gotta do some wiring. Okay. What are we doing? 91. Remove the top nut lock washer from the SPST toggle switch. So it is time. So I'm gonna move my elevation duder out of the way, and this guy here goes from flipped to normal, and I think they all line up. Am I wrong, or am I right? I don't know. I don't know right now. I don't know. But I know it goes here. So I'm going to remove the top control nut and the lock washer. Screw the bottom control nut so they're probably 1/16 of the body of the switch. Oh, yeah. Okay, so about like that. Insert the threaded shaft in the main. Insert the switch. Ensure that both sides... Okay. Okay, so you do use the lock washer. So we want to have on and off markings facing the outer rim. Okay, good. So we're going to go up and in like that. I think we need more. Yeah, we do. And then we go lock washer. The locky bits need to go to the 3D printed material. And yeah, that's going to do it. And then that goes on there. Yes. I'm already seeing a correction from Dave for something that I definitely did not do. All right, let's go back to the chat because Josh already screwed something up. Chat, what's going on? What have you got for us? From Dave, did you miss mounting the other Sonic hub to the base? Probably. I'm almost sure I did, Dave. Let's see what he's talking about. Go into the replay. Where is the other Sonic hub? Maybe I'm there right now. Yeah, I'm there right now. I haven't gotten there yet because it's not. I got to do the switch first. And where is the other Sonic? There it is. That goes later. That's the other Sonic hub. We're almost there. We're almost there. Okay, we did that, right? Am I... Dave? Dave, am I good? I think I'm good, bud. I gotta say, brandy and Coke is probably really good. I don't know how many of those I could drink, but... Uh-oh. Over-under on Josh having parts left over is already in the chat. Does the rotor have a slip ring so it can be left alone? A slip ring. No. Uh-oh. Dave is going, he's so confident he's pulling up the instructions, and we will. There's only one other Sonic rotor, or Sonic, because Dave, I haven't done the assembly yet, so the Sonic has got to go on this, but this has got to go on top of this plate. So it's got to go like that, and then the Sonic. So I think you got to stack it all up before you get to the Sonic. What are you caught on? All right, there you go. Could be wrong. I actually will take a moment here just to double check, because I'm pretty sure there's only two, and this is when it gets added right there. This guy. Oh, no. 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 No? This. No, that's not it either. So go back. That guy. Okay, I think you're right, Dave. I'm now on Team Dave here. I think you're right. There, that guy, right there. We got it. Okay, we found it. We found it. I jumped over it. So yes, that needs to go in with two. Yep, step 81. Dave's already on it. He's got it. He's keeping me honest. 377 people watching me here. You just want to know if this thing's going to work or not, don't you, chat? You just are like, there's no way Josh is going to get this. Ye of little faith. I know the electronics already work. We've already tested that out. So this is a bit backwards. I did this a little wrong, so we're going to have to go... What? How's it? Oh, it's recessed on this side. Easy. Okay. Okay, what does it say to do? On one side, the Sonic Hub circular key, the recessed portion of the mounting hole is designed to accept the key and ensure it's perfectly centered in the bracket. Now install the hub. You're going to use two 6mm. So those ones, 6mm should be these guys. Oh. That is just very lightly tight, just to kind of line it up with the holes here. Oh, God. I love magnetic heads for PC builds, but sometimes on stuff like this, I don't desire it. Already in chat. Ye of little faiths. Okay, now we have... I did it wrong. I should have looked. I knew it. I knew I was gonna do it wrong. I knew I was gonna do it wrong. So, those are set screws in the side there, and I can't reach them where they're at. That's funny. Oh, there it goes. Okay, so these guys need to be facing in such a way that I can actually reach them. So we're going to line the holes up. And that's the way you want it. It's like the guy who designed it knew what he was doing. Okay, fantastic. Thank you, Dave. Thank you, buddy. All right, so that stuff's placed. Now we can continue back with our final assembly. I have no guarantee that I did not drop itty-bitty pieces. He lost a screw. What? Don't start that. Don't start that business with me. Okay, locate the elevation motor assembly created. Plug the connector into the L motor. Okay, so here is our motor. It needs to be. Oh boy, how does that go? It goes from the outside. Oh, because we're gonna shimmy this in. So, oh man, this is wild. This is wild and crazy stuff here. I'm tightening these nuts up a little bit. Okay. Okay, so this motor needs to connect to CN2. Which is that guy right there. That guy right there. So we're going to go down here. Okay. And locate the elevation. Locate the elevation potentiometer cable assembly created. Okay, I've got that. So I think the as CW and C counterclockwise needs to be plugged in. Where does that go? Where does this guy go? I've got to plug that guy in now. What? What are you talking about? The ESP32 is shielded? What are you talking? He didn't give me anything. He said, "Here's your kit. Here's your kit, sir." Oh, Dave, what am I missing, Dave? Pretty sure I missed plugging in something, so I'm going to do that right now. Yes, we gotta plug in these switches. Okay, and then this guy should go in like that, making sure we're not crimping any wires. Look at that. Oh wait, you're not seeing it. Hold on. There you go. So I had to plug in some of the plugs there. So now we can put that on top. Back down. Fit the main body layer on top of the main body layer 1 and secure with the 4 6 and 30 seconds by 1/4 inch pan head. So that is these guys, I think. And this is another over tighten because it's 3D printed. Oh, calm down. What's going on here? There we go. This is a beautiful little setup, though. I will be riding right out to Harbor Freight, likely tomorrow, to get this beautiful steed, a chassis made of the finest Harbor Freight clone waterproof container. Good. Look at this. Well, what'll happen is you'll thread out the base of the screws, and then they won't hold. You can use super glue to hold them together if you get to that point, but best not to get to that point. Well, how dare you, sir? First of all, but it's $320 the kit. While holding the main body layer, route the 2 elevation cables assembly that are coming from layer 1 through the corresponding routing hole in the floor of layer 3. What are you talking about? What? Oh, those guys. Oh, I screwed all the things together, and I shouldn't have done that, should I? I didn't feed the wires through, Dave. I got so excited. Well, the good news is our 3D print threads are well bedded, so they'll go in nice and good. You don't want to do this a lot of times. I said no time for the wiring assembly. This is wireless, yes. The whole thing is wireless. Control is wireless to your PC. Okay, so I did bodge up a couple of wiring harnesses. They are the aforementioned wiring harnesses. So we will get him out of the way. It looks like we're missing some wire. Okay, so I got all the wires, but hold on. Where do these guys go? Let's find out where the wirings go. Locate the elevation motor assembly creator. Plug it into the L motor CN2. L motor CN2. That's that guy. Okay. Locate the no. Where is it? Remove, insert the threaded hole, place lock washer, able assembly, created and plug it into L motor CN2. Okay, that's this guy. Elevation, though. Oh, so this is the wrong one. Okay, hold on. We had our motors plugged wrong here. Elevation is the rotating, the teeter-totter head. Up and down. The sciencey term, up and down. And then this routes through the hole in the front. And then we got another guy. Locate the elevation assembler extendo cable. This goes into CN5, which is this guy. I'm going to go ahead and turn on my soldering iron, too. We're going to turn on the soldering iron because we're getting into soldering town, I think. Getting close here. All right. Now we have everything routed correctly. Let me get these wires out of the way. Reseat this guy in. Not crimping any wires. Good. Now we can close it. For those that are curious, yes, we will do an after chat. Well, what is it, 6:30? Yeah, I think we still have time. I think hopefully we can get this done around 7 o'clock, making this a good proper 2-hour live stream. But I'm finishing it tonight. It's getting finished tonight. And yeah, so now we got our 2 wiring harnesses out here, like so, kind of, sort of. Yep, those 2 wiring harnesses are coming out the side here, which we're gonna attach to our. Oh wait, that's in the wrong hole. Oh boy, guys. So maybe not 7 o'clock live stream after chat. Maybe not. Maybe not. We'll see how it goes. We'll see how it goes. Hang on. Dave, it's too late. We've already committed. I love it. Right now, this is non-destructive, what we're doing. We're just wasting time. Dave called it. He did. I'm sure whatever Dave called, he called it right. Okay, so these bundles, let's get those bundles up through the appropriate hole. Got it. Dave approved. Yeah, these threads are well bedded now. Well bedded threads. And like I said, I can just super glue them down if there's a problem, but right now they're fine. I didn't tighten them down that much. Good. Seal of approval from Dave. It's amazing this guy's even a father. Can't even find the right hole. And we did it. There we go. We did it. Very good. All right. Plug the connector, azimuth motor control. You will have a position. Let's see. While continuing to hold the main body, route the 2 elevation cables through the hole. Carefully tilt the main body into the azimuth motor. Main body is shown. Ensure the cables were routed in the previous step. Fit the main body. Use the 4 pan screws. Do not over tighten. Okay, that's where we're at. While holding the main body 3 above the 2 layers, route the 2 elevation cable assemblies that are coming from layer 1 through the corresponding hole in layer 3. So, here is layer 3. Corresponding hole, everybody. Right here. Maybe. Okay, now we still have this guy to deal with, so hold on. Likewise, route the potentiometer cable assembly through the rectangular hole, which is right here. Oh, goes in the square hole. Right there. And I'm going to grab my... Oh, no, I got it fed through. We're good. It's already fed through the bottom here. Boom! Likewise, route the cable assembly. Snap the main body layer 3 to the main body layer 2. It doesn't snap. There's no snapping. Dave, there's no snapping. Dave, it doesn't snap. It's not snapping, Dave. Dave, it's not snapping. It looks like it could snap, Dave, but it's not snapping. There's no snapping. And using needle nose pliers. Okay. So now we gotta get the this important wire into that plug here. And we'll rotate this. Wrong way. Whoop. Bingo. Got it. I'm panicking, Dave. It's not snapping. Instructions say to snap. Okay, prepare the 30-tooth 6mm D-bore pinion gear. Our last pinion gear right here. This is the 6mm D-bore 30-toother. I don't even know where this goes, man. Okay. Yes. Yes. Maybe. Can't be. Okay, hold on. Hold on. Consult. Nope, he's not there, man. Insert socket head screw into the threaded receptacle and loosely screwing it so it just peeks inside the gear shaft opening. What? Oh. What? I'm sorry. What is happening? Wait, this is not right. Something's not right here. We're going to need Dave again. Where's Dave? So we are at the prepare the 30-tooth by inserting its socket head set screw into the threaded receptacle and loosely screwing it. So you just, okay, yeah. Slide the gear onto the azimuth shaft, which is the left-right rotation, counterclockwise and clockwise. And gently mate its teeth with those used on the azimuth potentiometer gear. Flip the gear. Will they even mesh? Wait, this is not going to... Hold on. Hold on now. Hold up. Oh, they mesh. They totally mesh. Never mind. That's my bad. But it needs to be... Oh, because we're going to go through this opening here to tighten it down. Okay. Gently... Okay. Slide the gear in azimuth and gently mate its teeth with those of the azimuth. Continue to slide the gear towards the azimuth motor until it contacts the shaft coupler. Okay, it is now contacting the shaft coupler. The teeth of those gears should no longer mesh. They are in fact meshing. So I've got to back out the potentiometer a little bit. Nope, wrong one. Nope. Nope. Okay, those gears are no longer meshed up. Yeah, this is lovingly lubed with bacon grease, everybody. So just cool your jets. Yeah, so this is where, again, it's reiterating a very important point. The purpose of the next 7 steps is to set up the motor assembly so that you can temporarily position the azimuth motor shaft so that it will point the antenna's mount arms at 0 degrees from this position. The rotor will only be allowed to rotate clockwise as it's a hard mechanical stop for any further clockwise movement. Once in this position, we will continue with the normal final assembly. Okay, so interesting. Temporarily route the cable assemblies through the side holes in the main body. All right, so we will orient like that. All cables are now routed. Temporarily place the main body top plate onto the main body layer 3 by orienting it as shown and snapping it into. Now, this will snap, so let's rotate. We're going to rotate the assembly so my little doohickeys are here. And then if we take the top plate, which is this guy, and we align, it will snap. There will be snappage, and yes, we have now snapped it. No, wait. There we go. Snapped. Okay. Wow, this is getting serious. Oh boy. Orient the hub opening in the base of the elevation motor bracket so that its flat side is aligned to the flat side of the azimuth motor. Gently slide the hub on loosened. Jesus, what is going on? Orient the hub opening in the base of the elevation motor bracket so that its flat side is aligned with the flat side of the. Okay, sure. Gently slide the hub. Okay, so all it's saying is the sonic hub and the shaft needs to be aligned, which it is now. Great. And then I can rotate that to where the holes are showing up. Ensure the white. What? Wait. No screws yet? Oh, no screws. Wait. Okay. Oh, okay. Now it's getting serious. All right. So we have a thing aligned here, guys. It's aligned. Everything's it's all put together. Ensure the Wi-Fi hotspot. Yeah, a companion. Then apply 12 volt to the motor power. Boy, we're going forward here. Oh my god. Oh my god. All right, I'm applying 12 volt power. This is slightly scary. The light came on in the interior here, so this is all good stuff. Okay, hold on. Okay, hold on. We're gonna have to switch things up a little bit. Yeah, hold on. How bad is it messed up? It's not messed up at all, Tom. What are you talking about? It just took a while to set it up. That's all. All right, so we still have the Wi-Fi board connected. Where is our Wi-Fi board? And let's send a wake-up call. Yeah, we're connected. So you can see that there. This is reading the rotor. So let me slide this over a little bit. Note the azimuth angle being displayed is on the application. If it is 0, use your fingers to slowly rotate the azimuth potentiometer until the angle reads any non-zero value. Okay, we're gonna need the overhead camera here. This is getting serious. All right, so I'm gonna take my little finger here, and I'm gonna watch the dial. Maybe. Yes. I'm doing that. Note the azimuth angle is being displayed. If it is 0, use your finger to rotate 40.2 until. Note, the reason for this step is to fool the rotor's controller that is safe to manually rotate the azimuth motor and use your. Oh boy. Okay. Click the calibrate menu option to once again place the motor into calibrate mode. Okay, here's our calibrate. We're no, I want it to be, there we go. So let's put it there. Note the reason for this step is the fact that the manual movement toggle switches are not enabled unless the motor is in calibrate mode. Okay. This is getting wild. Use the manual azimuth movement toggle switch in either clockwise or counterclockwise to rotate the elevation motor bracket so that the raised arrow on the... What? Raised arrow on the other side of the bracket at the base is pointed to the center arrow on the main body. We got that? We got that? Hold on. Let me give our overhead back. This thing's crazy. This is, there's a lot going on here, guys. I'm definitely the part. Well, yeah, that's the part that's scaring me, is I get to make things move. Yes, we are going to calibrate. I am at the point now where I need another beer, though, so hold on one second. Obviously, that's only going to make things better. And you may ask yourself, what is Josh drinking today? Today, I'm having a Sierra Nevada hazy little thing. Dump this right on top of our rotor here. Hold on. What time have we got? Oh, we got 15 minutes. Come on. We need to get this thing done in 15 minutes. You kidding me? Come on. Have you seen me build kits before? Okay. Good. All right, here we go. So we are going to use the motor, flippity gibbet here. Use the manual azimuth counterclockwise to rotate the elevation motor bracket so that the raise... We haven't done the screws yet. So, okay, where's our arrow? There's our arrow. And it should line up with what? Oh, just down the middle? Bracket's base is pointed to the center of the inside of the main body. Okay, here we go. Oh my God, it's turning. Yeah, that's spot on. Tom, it hasn't got bad at all. Oh, I do have to pee. Yeah, I do have to pee. We got ourselves azimuth right now. We got it. This is considered 0-degree location. All right, we have zeroed the azimuth. On the calibration window, click the next button repeatedly until the changes say done. Do I need to click store? Wait, hold on. Okay. Next. Done. Okay, done. Remove the power cable. Okay, good. I feel safe again. The azimuth shaft position setups are now complete. Please continue with the remainder of the final assembly. Carefully remove the elevation motor bracket from the main body top plate by carefully sliding the bracket's base hub off of the azimuth motor. Okay. All right, so now we've zeroed the motor, is I think the point of this. So we're going to take the top plate off, and it just came right off, which it should have. All right, we're going to go back to the overhead here. Continuing on, we're sally forth. Yeah, this is no joke. Kyle said it's going to take about 6 hours, and so that's why I built the electronics, so that we could just get that out of the way, which I'm glad we did. This would take a long time otherwise. So, all right. Now, remove the top plate from the main body and set it close to the layer so that the elevation wire assemblies can be routed through the top. Ooh, interesting. We're routing cables now. All right. Here we go. This is top plate coming off again. And there's a slot here So we're going to take our wire cable. Wow. This is cool. Okay, so we got to go up and through here. Apparently, I made these ones a little too long. Right? So we're coming up through. Yeah, this way. Come on. I'd like it if these ones were not all twisted up here. So there we go. We got them separated. You gotta keep them separated. And I don't remember how this went on exactly. So hold on for that. Oh, God. Oh, my God. Loosen the 6 panhead screws attaching the square ball bearing turntable to the base of the elevation bracket in order to provide enough room to snake the elevation motor and elevation angle potentiometer wires, and about 1/8 inch should be sufficient. Oh, so we got to route through there. Which way did this go? So hold on, I don't remember how the top plate aligned. So this slot here needs to face the switches, which makes sense now that I look at it, but okay. So we are going to loosen. I'm going to leave this like this for right now. Just like that. And then we got to go. Oh my God. Is there a slot? There is a slot. It's right there. Oh, wow. This is crazy. The slot on both sides, actually. Oh, so one's got to go over here to the motor, and the other's got to go over here to the potentiometer through that hole. Okay, so potentiometer is the 3-wire. I'm glad I separated these. So I think I don't need to loosen anything. I could be wrong. Yep, I'm right. And then these guys need to go this way. Very smart. This design is really cool. I love this thing. Now, keep in mind for this satellite stuff, nothing is easy, guys, and this is difficult. Like, you may be watching this going, oh my God, Josh is really boning, screwing this up. But to be honest with you, like, it's actually very well thought out. All of this is very well done. Okay, so now we've got our potentiometer is a 3-wire. Our motor control is the 2-wire. And trying to keep these from getting kinked up with each other, and then they should slide freely. They do. I'm gonna place it here not because I'm finalizing anything, but just because I want to have an easy position to work on. Oh, and then nope, I did that wrong. Do it over again. And yes, I'm doing it over because I don't want the wires to get all tangled up. So realistically, it needs to be like that because the arrow needs to point to the front here. So realistically, we need to switch these like that. And then do it again. Cool. Fantastic kit. This is really fun. Even when I'm live streaming to 363 of you. The red wire's being fussy. Stop being fussy. Yep. And we have our 2 wire sets here. Nice. This is just free spinning, though. I don't like that, but oh well. No, I know. Well, the potentiometers have a slot here. I'm gonna do that. Oh, that's why, because you got to go. I see. Okay, so that is gonna be a little fussy. Yeah. Okay. Now you do have to unscrew it. Dang. So the motor cables are fine, but the other cables are a little fussy. So let's switch to. You do need a bit of a gap for those. That sucks. Yeah, I understand why you got to give it a little bit of gap. So, all right, these guys got to go through. Let's do this all at one shot here. Oh my God, that's hard to get it in there. Okay, there's those two. Okay, here we go. Needle nose. Okay. We got the motor control wires fed through. Good. Now we need to go up through here and then back in for the potentiometer. No cut. Well, yeah, there's a half circle cut out, but oh yeah. Oh yeah. And then these guys go through there. What? Fantastic. Let's do a little movement of the wires. I'm gonna button all this up in a second, but right now I just kind of want to get this down so I can eventually gonna have to do some soldering. Okay, wires out on each side. Wow. Putting a small bend in each of the wire will make it easy. Up through the hole. Retighten the screws. Do not over tighten. Leave the slack in the hub. Okay, well then we got to pull some back out. Hold on. I got plenty of slack. Okay, so we got extra wires here and there. I'm making hecka process, man. Come on. Or progress. We're killing it right now. Look at this. Main body side with switches, elevation motor side. I think he's focusing on the rotation there. So ensure the excess wire has been pulled out so they appear as they do above. Okay. Slide the elevation motor bracket. Okay, let's go back and tighten up the screws as recommended. Oh, magnet's strong. Okay. Wow. Crazy. The kids have their second competition tomorrow, so I'll be roboting tomorrow with the Vex IQ team with the kids. Dave needs to get himself a beverage, apparently. He's a little high-strung right now. I can't imagine why. I don't know why he's so upset right now, but yeah. Thank you, Dave, for all the help. Okay. Moving along. Ensure the elevation wires are routed counterclockwise around the shaft. Oh, okay. Well, let's do that. Ensure the elevation wires. Okay. Yeah, they were not, so I will do that now. Counterclockwise. In fact, I'll pull more through because I've got some more. And a little bit of the extra power cables as well. So they are well counterclockwise. Wow. Okay. Slide the elevation motor bracket base back onto the azimuth shaft while ensuring the elevation motor are not being pinched. I did. Use a 3mm Allen wrench to tighten the 2 socket screws on the bracket's base hub and slightly down pressure while tightening the screws to ensure that. Okay. Okay, here we go. So we are going to tighten down our sonic screws with some slight down pressure. Oh, this is apparently the wrong size. What? What size are these things? Okay. Okay. Oh, Lord. Slide the elevation motor bracket's base hub into the azimuth motor shaft while ensuring the elevation motor. Yep. Apply. Okay. 3mm. Put a slight downward pressure. Screws. Body. Hold it together tightly. What is moving? Wait a second. Oh, because those aren't tightened down yet. Okay. There's still a lot of loose stuff in here. We're going to go through the whole process right now, I think. I don't like the fact that we have to switch between different sizes of wrenches. Okay. Apply the 12-volt power. We're back to applying power. Scary times. Apply 12-volt power manual and use the manual azimuth toggle switch to rotate the elevation motor bracket as needed. And use as needed to allow you secure. Oh, okay. So we're going to rotate now to secure the top down. Okay, here we go. What? Oh, what? Oh, wait. Are we in? I have to put it in calibrate. Okay. That's it. That's so cool. That's so cool. I love it. This thing's awesome. I'm so glad I bought this. I promise, Dave, the next time I build something, I'll make sure that we have a faster latency than what we got right now. Because right now I'm on normal latency, which is probably, I don't even know how many seconds, but too many, sir. Too many. Oh, that's not going to be good. I don't like that. That's going to be hard to tighten that one up. This is also not going to be great, but still not bad. Okay. And let's give it a little juice here. Yes, right there. It's kind of cool. It's got a little ramp up. This is when it's going to get serious, guys, because we're going to hit it with the we're going to hit it with the elevation motor here. We're going to get those potentiometers soldered up and probably ratchet this whole thing down, and then we're going to have a full-on beast here. Okay. We did it. Remove the 12-volt power source. Here we go. Route the elevation potentiometer wires through the small hole and use the left of the elevation potentiometer shaft as shown in the right image. Leave a little slack in the wires pulling through. Prepare the elevation potentiometer wires by trimming them to length where they can easily fit lugs and won't create a loop when hooked up to solder. And discard the wires that you need. Strip about 1/4 inch of insulation and twist and tin the exposed wires. Connect each wire to its protective solder lug on the elevation potentiometer as shown. Trim any excess wire. Okay, so here we go. It's getting real. I'm going to have to do it from this side because this guy's in the way. Can I rotate this? I'm not going to try. I'm going to break the damn thing. Yeah, I got to do it from this side. So let's see. It should be, as I'm looking at that, it should be red, black, yellow. When this is on the right side. Right now it's on my left side, so I'm doing it in reverse. So red, black, yellow, and perfect. Oh, man. It's going to get a little tight here. I'm going to give it just a little bit extra for, it's a little bit of gap. Yeah, that's fine. We'll just go with that. Oh, no, they're too short. Okay. Here's one. Two. This is when you really get a little scared. 3. Okay, so what do we say? Red goes back there. These are a little bit fiddly to get into place. Okay. Oh, no, come on. We're going to play one of those games today, huh, guys? There isn't really a better way of doing this, but this is not ideal. You really got to twist these wires too. Hold on. Okay, I think we got the red wire fixed. Hold on, I'm going to hold it there for a second. Then the black wire. Black wire is secured. And now the yellow wire. And the yellow wire. This is ASMR. Kit building with Josh. If you enjoy this kit build, it'd be great if you gave me a thumbs up. Show your appreciation for builds like this and future builds. All right, now we've got these. They're in place good enough. Doesn't matter. Maybe not as fancy as Dave's. All short and good looking. Oh, yeah, I can push it back in the hub once we get it. Let me go ahead and get these in place here. Let's see if I can show you a little bit of the solder action. I think you can see some of that yellow cable maybe. Hold on. Maybe? Can I zhuzh it in there for you a little bit? I would rotate this, but frankly, I'm not gonna. I'm just gonna do it because I want it to be done. Yellow is affixed. Black is affixed. Oh, this is a little tight. Red is affixed. Is it? Oh, yeah. Definitely affixed. Okay, that was the hard one. This one's the easy one. The motor. Oh, I don't want to lay it down. I guess that was a bad idea. Don't do that, Josh. Jesus. However, it does only go in one way. There are lugged out areas there. So we got that. It's motor time. Oh, this one wants heat shrink, so no problem. We do have our piece O heat shrink here. So we get about that much. About that much. Bam. And what side is red? This is the black side right there. And there's the red side. Okay. Easy. Oh no, you want to solder these. I wouldn't do anything other than solder these in place. There's no way I would do anything less than that. I don't know if I doubt the instructions say, yeah, no, it says to tin and solder. And we're applying some heat shrink here on both wires. And I am going to tilt this a little bit for better view. The only wire that's a pain here is this red one is going to be kind of difficult to thread. The black's good. In fact, I'm just gonna tack it into place right now. I'm gonna get the black out of the way right now. Solder me up, Scotty. Black is in place. I'll worry about the heat shrink in a second. Once I get red sorted out. Well, we've passed the 7 o'clock mark where I thought I would be done. We are not done. Not how I'd want to do it, but I'm going this direction now. Yes. Okay. Got that into place. Yeah, screw it. I'm doing it. I'm laying her down. Gotta lay her down on this one. Okay. This is kind of a tight fit, so I just have to do it this way. That's good. Okay. Now, with it in this position, I'm going to get the heat shrink tubing routed over. Actually, I take it back. I'm going to do it this way. Where are you sticking on? Oh, this is pre-adhesive heat shrink. That's why. Thank you, Norm. Appreciate the super chat. Thank you for the $5 there, buddy. Says I didn't cuss as much as A0Z did on his live stream. I could see why. I did have a Pocket Dave, though. That helped tremendously. Thank you again, Dave. So, okay, there we got it lined up, and I think I've already got this plugged in. So hit it with the juice. Bam! Yeah. Okay. This is out of 0 now. I don't know how we... Okay, whatever. So nothing's lined up yet. Nothing is calibrated. Everybody's upset. Okay, so what's next? This completes the physical assembly. Please leave the Wi-Fi hotspot in place. Also keep the power applied to the rotor. We're going to calibration here. Okay, so, Jesus. My heat gun's trying to kill me right now. All right, we're at a break-even point here. I want this to elevate, and I want it to do more azimuthing, as it were. But I really need to use the restroom. So I am going to take a break here. My top should not... Yeah, because the bolts aren't screwed down. set screw on the bottom motor. I don't know what to say. We'll deal with that in a second. It said not to. It said to loosen that one. I need to use the restroom, so I will be right back. Literally, enjoy the memes. I will return. This is almost turning into a 4-beer project here. This is turning into a 4-beer project. Uh-oh, the top is not supposed to be that. I know you said that earlier, but yeah. Okay, let's get back into this. Where are we at? Okay, we'll deal with that in a second. Let's see where we're at. Also, remember, like, none of the gears are mesh for the potentiometers yet. Like, we're not at that stage. So, but I could be wrong. I probably am. In this section, you'll be using companion Windows app, perform the gear and potentiometer alignment procedures. You'll also be using the application to calibrate the rotor's azimuth and elevation. Please perform the following steps to complete the elevation. Okay. Open the companion app, proceeding to calibrate from the top menu. Okay. You guys got me worried about this rotation thing. So let's look. Let's look. We're going to do it right now. Here we go. We're going to figure out what's going on. Do it right. Okay, so we do have some play here, and it's obviously not any of the mounts. We do have rotation. In fact, how much do we have? So let's look through this here. The bottom, you can see the gear rotating inside, maybe. Yeah, you can see that. And it looks like that's rotating. Is the motor? Can I? Huh. I'm curious. No more. No more wiggle wobble. Okay, so the rotor's all out of whack right now. We got to sort that out. So here's the switches. They're right here. We got to do that again. the coupler from the shaft was loose. My shaft coupler was a little loosey-goosey there, kids. We got it sorted out. Oh, this will easily swing your tape tenna. This will handle an arrow, Steve. This will handle an arrow and an elk. The elk is lighter than the arrow. This is meant to run an arrow. You put it on a tripod. It's got a threaded base, and it'll run an arrow. The creator runs it with an arrow, and he runs it like with a lot of forward weight. You happy? You happy? Imagine not having a loose shaft. I know, kids. That's what we got now. We're good. All right. Open the companion app. We have clicked to the calibrate. We are on calibrate step 1. Wait, so, okay. We still haven't meshed some of the gears, as I think it called out. Calibration diablocks, calibration procedure. Ensure that the lower antenna mounting arm is still straight up and down. I didn't ensure the lower antenna mounting arm. What is the lower antenna mounting arm? It's not. Because it was never installed. I didn't install it vertically, guys. Because the motor. Well, can we just go up? No, we can't go up. Oh, because there's no 12 volts. Helps if I follow the instructions and just left that plugged in. All right, let's give her a second here. Let's just see it go up. How about that? Let's just see it go up. Right? Let's see. Ain't goddamn thing. We don't have Wi-Fi. We'll send the wake up. Let me get out of here. Okay, we got wake up. We got wake up, kids. We got wake up. Let's try it. Here we go. Oh, no. No. We don't have it. Okay, what? The light is on. Do we have azimuth? Oh, we don't have. Oh, because it's not in calibrate. God. Okay, now we're in calibrate. Yes! Ha 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 ha! How about that, Steve? The other Steve, Australian Steve, not not New York Steve. Look at that! So we haven't. So what we're doing is we're trying to zero everything, right? So there's arrows in the front. In fact, let's zero. No, wrong way. We're gonna line up the arrow right there. The arrow should line up right here, where my thumb is. Right here, where my thumb is, and stop. Yeah, it's pretty much close. Yes. 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 All right. Okay. So we need a little counter action, counter rotation. Uh-oh. Now we got real trouble. My wife just texted me. Now we got a big problem, guys. I'm almost done here. How soon do you need me? She's going to say now. No, it's in calibration mode. So we're setting zeros, and then we're going to tell the app it's zeroed now, kids, because we're going to mesh the gears, which tells the potentiometers. Forget everything you knew about where we were before. He's telling us it's zeroed. So that's a fantastic way of calibrating. It's all over but the calibration. Yeah, she will get in chat. She will get in chat right now. Okay, well, she hasn't replied yet. I've got the phone pointed at me. Yeah, so everything, nothing is meshed right now. Our azimuth potentiometer is not connected. Our elevation potentiometer is not connected. We're going to follow the instructions to zero it out, and then we're going to mesh everything. And then we're going to say, boom. That's it. And then you're locked in. I don't know if there's a safing command. I'm assuming there's a safing command where you take the antenna off, you click safe, and it drops it to 90 or something. Drops it to true 90 so that you can take it off and like lay it flat kind of thing. Don't know. Really don't know. Okay. Ensure the lower mounting arm is straight up and down. So I'm assuming lower antenna mounting arm is the vertical that we just did here, right? That's straight up and down? 0 degree elevation. Meaning if you had, so here's the elevation arm, and if you put an antenna on it, then that would be at 0. It'd be aimed perfect 0. I know, exactly. There's got to be a stow button. That's what I'm looking for. I'm looking for safe or stow, right? How do we safe all these feeds? As performed, if not, use the manual elevation toggle switch to achieve it, which I did. Use your fingers to adjust the elevation potentiometer so that the E volts as seen in the lower left is between 15 and... Okay, cool. Now we are truly doing this. So now we got to go back over here. And we're going to drag this over here. That is the elevation potentiometer. It is not correct. Right. I'm sorry. Azimuth or elevation? What are we doing? The elevation potentiometer. So if I go in here, let's see. Watch this. Oh, yeah, kids. See that? So we're hand jamming the calibration in. What am I at right now? What do I need to get it to? 25? Between 15 and 25. And that sounds like 20 to me, which I nailed. I nailed it. It has a home function. Well, okay, home and safe are like the same thing, basically, for all intents and purposes in this case. Oh, she just replied ASAP. Okay, well, there you go. Basically, what has to happen right now is I'm going to adjust the potentiometer for the voltage that the potentiometers are showing, and then I'm going to mesh the gears together. And then that's it for both elevation and azimuth. And then it's done. The software, thank you, Frank, just in case. Yeah, it doesn't sound like there's going to be an after chat. And I have, Josh, I have news for you, and you have a message from me. Okay, I will check it out. Thank you for the super chat. Who else is old enough to remember parking a hard drive? That's a real thing. I remember. Pepperidge Farm remembers. So that's it. So basically that's it. I do have to mesh the gears. I got to set things to 0. I'm going to leave this exactly as it is, but I've been told I have to go help for robots tomorrow. So I'm sorry. There will be no after chat. We have been overwritten by the wife. So I will say a huge thank you. I really got to wrap this up. So she has said, you are done, sir. Okay, on my way. And that means I got to like drag some antenna stuff out of the back of the truck, the bed. Big thank you to the patrons. They allow me to buy things like this crazy rotor. So it looks like we can take some slack up on all this stuff too. So this is really clean. I am quite happy with this. Knowing that it'll handle the elk, which is like my favorite portable antenna. Nothing wrong with the arrow. I bought the mounting, but we didn't even get to the mounting plates. I'll grab those real fast. So he sells mounting plates for, this is the arrow mounting plate with the set screws on the side, and this is the elk one that will take the PVC pipe, and it has a little tiny set screw. And then they mount into the arm of the rotor for elevation. And so you just swap them out, and those are the ones you use. That's it. That's all there is to it. Easy. I'm now a little... These would be better if they had nuts on the other side, that you drove them into nuts and could tighten them down. I'm a little less happy about the I think they just go straight into... Yeah. They just go straight into 3D prints, which I'm unhappy about that. But I can just go get longer nuts and longer bolts and just use nuts for that. But yeah, there you go, guys. Highly recommended. Obviously, this isn't a performance test or anything like that, but it works. And so now the trick for me is I need to get this all zeroed, and then I need to figure out how to run all of this on Linux, which I don't have the solution for that yet. Now that I'm trying to move all my ham radio stuff to Linux, it's a little, we're one step away. But yeah, there you go. Appreciate y'all watching. Thank you so much. If you haven't, please go subscribe. Yeah. Man, that was a good one. That was good. I really enjoyed that. Fantastic build. Again, we will show the links are in the video description. Go check it out. But this is the WA4 MCM Kits PSR 100 portable lightweight satellite rotor kit. I did it all live. Appreciate that if you're doing this on your own, it's not difficult. If you've built a radio before, you'll be able to do this. It makes a lot of sense, particularly if you're, appropriately reading through everything. You don't need a Dave. You just need to read the instructions. The instructions are fantastic. I have dropped links to all of the stuff, including the SAT box, a couple of recommended antennas that you can get to make this work. If you want to run the SAT box, let me say this with the scant time I have. The SAT box is pre-configured to work with most ICOM radios, particularly the 9700. It works really, really well with the 9700. It will do other ones as well. It's fairly limited, though, on what it will work with. If you have an N76 or an N7600, the VGC radio, you can just use the Android app to control Doppler. You don't have to use the SAT box for that. You can use this for pointing, or you can just use a laptop or computer to do pointing for whichever satellite you're trying to hit. But there you go. There's the wrap-up for the whole thing. Thank you so much. If you still want to hang out in the Discord, go ahead and get it started. I don't think I'll be able to join, but I will talk to you very soon. Thank you so much for watching. 73. I'm literally shutting lights off. Oh my God, Brooks. Thank you, buddy. Thank you, sir. Sorry for going super long, but we got there in the end. Thank you, Brooks. Thank you, everybody. Thanks to all the supporters, the patrons, the super chats, and